Can everyone hear me?
Yes.
Okay, thanks. So I think the first thing we're going to do is we will continue our discussion of the on-demand API from last week. I have updated the slide deck just a little bit to kind of summarize where we were going with that discussion. We'll start by looking at a couple of those updated slides, and then we'll kick it open for discussion. And I will stop my alarm clock that is letting me know that the meeting is starting. There we go. Okay, so last time we talked a little bit about the operator requirements. I think Michael stressed some of those points, and the two things that I recall from that was there was the need for both periodic and an immediate API. Now, I think one of the points Michael made about the periodic API is that what mattered most to the operator was wall clock time. You know, that these statistics come on at 15 minutes past the hour, then 30 past, et cetera. Not necessarily artifacts due to the VOLTHA process and when it started. So it's not really important to generate statistics 15 minutes after the VOLTHA process started. It's more important to generate them 15 minutes um, after the hour. This periodic generation is automatic. It's not the case that the operator needs some process out there every 15 minutes saying ask VOLTHA for the periodic performance metrics. VOLTHA maintains this 15-minute timer itself. We publish everything, and we let the operator filter out later what the operator does not want. And although it might be nice to be able to configure this interval to something other than 15 minutes, it's not immediately necessary. It's probably sufficient that this is the compile time constant. The other requirement is the immediate API. And the requirement there is that some metrics and test results require an immediate response. Now, I put immediate in quotes because nothing is truly immediate. It does take us some time to send a request, and maybe the ONT needs to run a self-test and the response to come back. So that might take anywhere from milliseconds to seconds to maybe even tens of seconds for something. We don't really know. But the point is you're not getting intentionally cached old data, so you're not getting a 15-minute old data dump. It is a request that's happening immediately at your request. The immediate API would be synchronous and blocking. So it may come from something like Yang requests, where Yang request comes down and it does expect a response. It doesn't expect the response to come later via something like Kafka. And then some data may only be retrievable by the immediate API. For example, we might not want to be initiating self-tests on the ONTs every 15 minutes. We might only want those to occur when the operator is trying to diagnose a problem, or we might want them to occur at a really long delays, like once a day instead of once every 15 minutes for something like a self-test. Last time we talked about current approaches to the API in VOLTHA, and I think I pointed out that VOLTHA does have several different approaches. There were things that streamed. There were RPC calls that were asynchronous, non-blocking, and there were synchronous blocking API calls. We went through some examples of those. I'm not going to go through those examples again. And then I think we came up with a proposal, which was to handle this inside the NEM, where we would take the asynchronous behavior and make it synchronous. I think one of our guiding ideas on this was let's keep VOLTHA simple, which means keeping VOLTHA asynchronous. And rather than having many divergent implementations of performance metrics, let's converge on the commonalities between performance metrics. So we would keep VOLTHA using Kafka. We would use the same output mechanism for periodic and immediate statistics over Kafka. It'll just be the trigger is different. One would be on a timer, the other would be on a request. And then we would meet the operator requirements in the NEM. So the NEM can export its own API, which can be richer than VOLTHA's API. The NEM can turn the asynchronous behavior into synchronous behavior. And I think David made this point last time that whenever you're want synchronous behavior, somebody has to implement the wait loop that says, pause everything until this response comes in. And so if someone has to wait, let it be someone inside the NIM rather than someone inside of VOLTHA. And the NIM could also implement this wall clock batching. So I updated the pictures. So what I've added here is I'm calling it a proxy. One could also consider it in some cases be sort of like a buffer. We'll get to that in a moment. But the proxy would send out a request to VOLTHA. For the moment, assume these are gRPC requests. So there's a gRPC request that says, run an OMCI test. Immediate response comes back, which comes from the ONU saying, yes, I'll run that, and the results will follow. And then sometimes later, the result comes back, goes through Kafka, goes into the NEM proxy, where it ends up going back to the front end. So the front end over here could be something like whatever thing is handling the Yang requests and satisfying them. So the main point is this box over here is synchronous. It executes one request to the system and gets one response, whereas the asynchronous stuff is handled over here inside the NEM. I think David pointed this out last time that we could use Kafka for both requests and replies. There's no reason why this top one had to be gRPC. This NEM proxy could send a Kafka message, which went into VOLTHA, and then all the magic happens with the ONU over OMCI, and then a Kafka result comes back and goes back to the client. So one of the things we discussed last time is there would need to be a transaction identifier for these requests. So for example, in this picture, this NEM proxy, it has to match this request with that result. So it would have to put some token inside the request, and that token would come back inside the reply. It would be able to match those up and know to respond to the appropriate client. Now, if we want to do this wall clock batching thing, we could do it using the same proxy or a different process inside the NEM, whatever we want to call it. And here we would notice that there's lots of OMCI responses coming from the ONU. They all go through VOLTHA. They all come out Kafka, on their various timers automatically. They all go into the NEM proxy, and then the NEM proxy stamps them all as saying this is the 6:15 p.m. batch, which goes out perhaps via another Kafka or perhaps via some other mechanism to the operator. So I thought a bit about this. I think last time we said we might need batch start stop indicators to assist with categorizing these batches and putting the right requests in the right batch. So maybe VOLTHA would emit every 15 minutes and say, I'm going to start sending my performance interval requests. And then at the end, it would say, I'm done with that performance interval. I'm about to start my next.
Scott, on this one, can you go back to the previous slide, please? No, yeah, one back. I think why isn't, nope.
This one?
No, it was the one where all the things, that one.
Okay, we're here.
That one. Yeah, the clock. One thing I thought we had mentioned last time was that there wasn't anything really batching it up, because batching it up was a data process or analysis action. And so
I think that could happen at the layer above the NIM, perhaps.
Right. The idea was to publish it all to your time series database or something. And then whoever does the analysis, when you're looking at the data at 15-minute intervals, that's when it would be kind of bucketed or batched.
Yeah, so I think that was my next point on this slide was, do we even need a proxy? And is the batch identifier sufficient? So that would go to your point. Maybe we don't need to batch them ourselves. Maybe it's sufficient for us just to be able to identify the collection of results that go into a batch.
Well, I'm not even sure there's a batch identifier. Wouldn't it, as long as we have like NTP across the cluster, there's going to be a timestamp on the event. And then when you're looking to batch it, you know, anybody can timestamp it or batch it or average at 15-minute intervals, 20-minute intervals. They can do any data analysis they want. I don't think we want to set up a batch. We just want to give the data, and then the analysis would say, okay, I want to do 15-minute buckets, and they're going to grab the data and bucket it into 15-minute intervals with appropriate averaging if they got multiple events for a single metric, if you will. I just see that completely out above and out, you know, VOLTHA and NEM. It's just who's going to manage the data and do that analysis. I don't know what component that is, but there's no reason that we even have to decorate the data, I think.
Yeah, I think I agree with you on that point. I would like to talk to Michael and see how he feels about it. I thought he was of the opinion that he wanted more of this. He wanted these things to come out in batches. I thought I recalled that, but maybe I'm recalling incorrectly.
You're right. You're right. He wanted to have the data at the intervals, all the data coming at the same time.
Yeah, he wanted a big dump all at once, which I sort of side with David on this. It seems to me that, I mean, the data naturally comes over time, and it's an analysis step to make it all appear that it's all at once. But I guess my point with these slides was we could implement the all at once if we wanted to.
I think that's what you're going to do with that proxy also, right? I mean, you're going to go ahead and normalize the time and push the thing out. So end result, I think David is right. It doesn't make any difference as far as the functionality is concerned. It's just making it more complex. I kind of agree with David's approach.
Yeah, one thing is, so this is Tom Moore, and I hate to disagree with Mike, but I'm going to this one because there are discrete elements that go to Kafka, and Kafka provides the persistence so that an analysis function can determine what belongs from a 15-minute interval from what monitoring points and from what time periods. I don't think that the lower level is going to do that effectively. So if I'm understanding this correctly, so if I want to push the take the last 15 minutes data for the entire SIVA pod, I can do that. Or if I want to do it for all Ethernet interfaces in that SIVA pod, or all PON interfaces in that SIVA pod. What we do with those external adapters on the northbound of Kafka would do that, and those could possibly be operator specific based on how their interfaces to, let's say, OSS northbound or automation system northbound are done. That's where I think we need to be precise about what we're asking for and expecting what the other interface can have. I see Mike has just joined, so maybe we can clarify this one more time. That's just my opinion. Hello, Mike.
Yeah, welcome, Michael. Okay, are you on audio?
So can we go back to the previous slide, the one with the multiple pictures? Yes. And of course, and Tom, if we look at this, I think it's hard to discuss this without describing what's more north of the NEM proxy or even north of the Kafka. I know we have the VES agent for the alarm related. So is the VES agent also applicable for the NEM proxy for the PM?
So the VES agent is not a SIVA deliverable. It is a specific operator implementation, because not all operators will use VES to ONAP. So, right. But your question on this picture is relevant. So how do we where is the VES agent? What are these components? I think that's what we need to talk through, to your point.
Right.
So the NEM proxy here is implying that to the right of the NEM proxy, there's this thing called a 6:15 p.m. batch, which applies multiple ONUs or possibly or other other things of a certain type being batched together for that time period. On the right hand side, to me, one of my questions is, what is the Kafka? Is it reposting essentially to the same Kafka service with a certain identifier, so that then and then further to the right would be the CEBA northbound adapters of choice, like VES, if that's your choice to develop that, or what is the
I guess I would assume in the production system that NEM proxy wouldn't exist, right? There wouldn't be a NEM component there, or the only thing to the right of pink is gone. VOLTHA, CEBA are all publishing events. Something, whether that's a VES agent or another yet to be named deployment component, is listening on the Kafka bus and doing something with that data. That could be persisting it into a time series database for evaluation. That could be running machine learning on it as it comes in. Really anything. I'm not sure it makes sense, in my mind anyway, to have NEM or anything say, look, I'm going to batch it at 15-minute intervals. If there are systems out there that can do this, why don't we just give it to them? There are time series databases, publish it to the time series database, query at 15-minute intervals, right? There's ways to do that without building the component ourselves.
Right. No, I agree. Because one of the things on the NEM proxy means you're proxying to something else. So I agree with that definition. Also, CEBA might actually have a load where you are built it. You're in an NEM proxy. Let's say that you have using Grafana in your CEBA, and you actually want users to go into to log into each CEBA and look at things, because you're doing that may be what you want to do, what your management model is, and then that's doing a local time series database. So we might actually, if you're taking the external, there are other things you may be doing, starting with the pink. So I agree with your definition, Dave.
Okay, thanks.
Okay. Mm-hmm.
So we're all agreed then we could amend this diagram to remove the pink box, and what comes out of Kafka just gets exported outside the NEM to destinations above that will perform the analysis?
Yeah, if you wanted to generalize the NEM proxy and and to the right, so starting with the NEM proxy to the right, that could be the we call it in RD the NEM adapters. So they're specific to the outside of CEBA, or simply NEM proxy. I mean, NEM proxy with the understanding it's not part of NEM. It's proxy. It is operator specific proxy.
Okay, yeah. So I will update this slide to change NEM proxy to NEM adapters, and maybe draw a dash line between the Kafka and the NEM adapters to indicate that is above the NEM.
Mm-hmm. Mm-hmm. Yeah.
Okay, good. That makes a lot of sense to me. So I think we've quickly resolved the issue of any wall clock batching to say that it's outside of our scope, which makes it easy. So the other question we had, I think, before Michael came on, was, do we need a batch identifier to identify that all of these results apply to the same batch, or is time synchronization and time stamping sufficient for the analysis layer above NEM to figure out which requests go in which batch itself? And the assumption was that the time synchronization would be sufficient, and we don't need NEM computing a batch identifier. All agreed on that point?
Yeah, that makes sense to me.
All agreed, given that the time stamping of the interval happens, the start and end time stamping allow that analysis. So where it's generated and the result is posted, and actually is far to the left as possible where you can timestamp. So if the hardware has the timestamps in it, then that's best. If you have a piece of hardware that doesn't have timestamps, then the time then a way to derive the timestamps, and I'm not sure how to do that. You have to know when it started, the collection interval, to know that. So but if you set up a process where VOLTHA is polling based upon an interval, we could say, okay, the timestamp of my next interval was when I polled after the last interval ended. Then I know how to in VOLTHA to timestamp there. Does that make sense?
I'm not sure if I understand. I don't think VOLTHA has the concept of time intervals. It has the concept of when an event was generated or when the data was pulled from a device. So it doesn't, right? And then something else has to say, what is my 15-minute boundaries?
Well, ideally, the hardware has so if you're talking about, this is a case of where hardware has registers. So the ideal case is your hardware, your silicon has the hardware registers that represent an interval, and then a way to get the time of that interval. That's the most precise form of time stamping. And we had a discussion last year where it's if it wasn't done that way, then what would happen is you'd have a process that, let's say you want to do 15-minute or 5-minute or 30-minute or an hour, and you have a regular process that goes out from pulses. So when the time period that you polled would be off of a clock that you would have to set up a poller process to do that, and then you would have you'd have to have some information about last period's end of time and the next period's end of time to make up for that. And I know there's some difficulty in that. I don't know that we ever really went into the detailed algorithm of it. It was around when you did not have essentially the hardware having a defined that defined timestamp and in a defined interval. It included whether even the hardware had the interval for, let's say, the last interval to go collect. If you didn't have that, then you'd have to poll and then have to timestamp.
So if the hardware has
there are some devices that don't even have any DIMMs at all. I mean, they're just accumulating count, and it's some of the hardware you have to handle that from above anyways, I believe.
So if I understand correctly, you're saying some of the hardware has here's a bunch of data I've collected. Here's when I started collecting, here's when I ended collecting, and here's the data.
No, not even that. Some hardware just has, I have a counter. You come down and read it whenever you want, and I will reset it. It doesn't have start, stop. It doesn't have anything. I just have a counter, and if you read it and tell me to reset it, I'll do that. Otherwise, I'll just keep counting. And if that overflows, that's your fault.
But that's
why I've seen a lot of hardware. And so the question is, in this time, someone sends a request to read that counter, and that the time of the counter is read is timestamped, and that data is pushed up with the timestamp that counter's read, and that's put into a database or whatever. That's how I see this happening. And then if I'm looking for intervals, then I'm just doing data analysis on that database as to, I want to see all my counters that I've collected from 6 to 6:15. Is that kind of what, again, that's how I'm seeing this, and I may be completely wrong, but that's how I'm seeing this.
I know I got on the call a little bit late, and I know that you guys kind of went down some paths probably before I fully got on the call, but I don't know. I don't know which systems are going to be doing this type of analysis. I mean, Tom, maybe you have some ideas, but today our systems are very regimented, and we're expecting to have complete sets of 15-minute data. Which system are we thinking is going to go off and create these 15-minute intervals if data is just kind of coming up willy-nilly?
We talked about the system above NEM and adapter, NEM adapter.
Yeah. Yeah. Let's.
But we expect the NEM adapter thing to be a time series database that OSSs are then going to pull 15-minute chunks out of. I don't know. I did not.
That's the part that we were in the middle of discussing before you came on. So when you look at this picture and you say your requirements for batching, those requirements for batching are going to depend upon what our external northbound requirements are for SIVA. And so there's could be a large variation in requirements here. What you do have in the Kafka bus to the left of it is you have, let's assume we have bins, or no, let's assume that we have results that represent a collection from time A to time B. Those are timestamps, and then the count, and against the specific, let's say ONU in this case, and or ONU port, or whatever the case may be that we're collecting on. So the Kafka bus and the green bus there will have results that would approximate coming in around a 15-minute interval. I think if we're doing any poll, if the hardware is doing the collection, I think we're going to have a very much more precise interval, meaning closer. Those collection points from time A to time B on all those points are going to be very close in time to a 15-minute, and those will serve what we do when we batch them up. I think that if we have a variation, that's going to be a result of the hardware having some need to poll, and I need to address something on that and put that on that side. So if you have some variation, if you can do analysis, though, we would have to take care of that. Say, okay, which collections are we actually going to use? You might have to throw some out because they might have such a variation, or you might have to push them to something else. But there's a lot of scale questions in there. Let me make a proposal about something. So I'll stop. Well, let me make the proposal about it real quick. I think this question of whether we have precision on the 15 minutes is really a discussion around where hardware does not have a register. And I think there's one other thing that we could discuss there, which is there's a VOLTHA adapter that's specific to your hardware type that is another possible point to take care of. I need to do a specific implementation for hardware because it doesn't have the timed historical register capabilities that I need. And should we possibly have the VOLTHA adapter take care of that instead of VOLTHA, so that it can be very specific about what it knows about its having to poll the hardware versus whether the hardware has a bin collection already built in. Does that make sense? That way we solve it on the left-hand side rather than and let the right-hand side do what it normally does.
No, I think so once you have the ability to set a number of bins, whether it be in the hardware or whether it be in the adapter, I think that as long as those 15-minute bins are streaming up, I think that is probably going to be okay. The concern that I have is the name of this slide is the wall clock, is how are we going to collect all of those things into intervals, and if we're going to have some kind of rather complex elastic store database search thing that's going to say, well, if I have any interval that happened to be between 00 and 015, I'm going to count that as a good interval. And it doesn't matter that it came in at 14, or doesn't matter that it came in, that it started at 14, or that it started at, I mean, if we have all of these things that are very disparate, and we start doing comparisons across the different things, let me compare my uplink to my ONU to my whatever, and I want to actually do analysis that says, oh, what are the counts at all of these different points? And everybody's 15-minute interval is wrong because they're not somehow synchronized. I'm worried about that fluctuation in the time. I mean, yes, I can say that, yes, they should be. I mean, as long as they're close, that's fine. But if they're just like, well, whenever I start up, I'm going to start counting 15 minutes.
So here's the thing. We're kind of talking about how we solve a problem on the left, and it is a problem. So given some experience in this area in the past, when you do have relatively precise intervals, so if you had a 15-minute interval and it was 14 minutes and 57 seconds, or up to 15 minutes and 3 seconds, what we have had, and this is speaking from an operator perspective, not from the perspective of less necessarily the network element. You don't fix, if you say CBA is the network element, the up to left of the NEM proxy is the network element where it collects the data from the hardware. You did have a start timestamp, a stop timestamp, and you have the ability to say, take the that delta, the time period that you actually used, and use that as the denominator that you divide by your 15 minutes and 3 versus your 15 to actually do your real analytics.
Yeah, I'm not as worried. I'm not as worried in the deviation of I've got 3 extra seconds versus I've got 3 less seconds. I'm not as worried about that as I am worried about when does the interval start.
So can I?
The intervals can be much more precise when they're defined in the hardware, because in the hardware it's been given a timer and it's going to do my last.
Only if we synchronize a clock, and we haven't talked about synchronizing a clock down to all of these devices so that everybody knows that I'm supposed to start my thing at 12 o'clock.
I agree with you. I agree with you. That's a detail in this that I agree with you on. You cannot get that precision without saying what is the time master, and actually every device has that concept, and then it has when it starts and based upon that. So I agree that has to be part of it, and this is where again I think that's more on the left hand side than on the right hand side. So let's try to solve the problems on the left hand side as much as possible, and then some of the counters here are not necessarily of the type that are require as much precision. I mean, if you're not doing capacity management, but you're doing okay, I'm informationally getting some information about per ONU Ethernet packet usage versus I'm going to capacity manage my whole Ethernet uplink. Those are different, and where you don't have this ONCI, variable and things like that. If that's another variable that takes you longer to go pull all your ONUs, and where you don't have ONUs, saving having a register saying this is my last intervals of collection. So if you don't have that, you can't even say, well, take your requirement which I agree with, is define the interval from a there's got to be a concept of a time at VOLTHA to say, I'm on this this is your 15-minute time interval, give it to all the devices, and they all count off of the same time. That way, they're independently running off that same time, and in terms of I time my intervals this way. Does that make? Yeah, and I hope I'm representing what your intent is.
Yeah, no, I mean, yeah, no, I'm not as worried. Me personally, I'm not as worried about as much the variation in the collection of a few, even a few seconds one way or the other. I'm not as worried of that as I am worried about the actually setting a distinct set of intervals by distributing time. Because I don't think we're doing that part. So that's the part that I'm worried about. I'm worried about just everybody just sending up results at whatever time interval they want to do, and that we're going to have some kind of AI-based search engine thing that's going to magically turn those into buckets up at the top. So I mean that's the part that I'm worried about. So yes, so it sounds like you and I are agreeing about distributing time. Now let's see if everybody else is agreeing about distributing time or not.
I'm still trying. Go ahead, Julie.
Okay, so I had Sean wanted to insert something here as well, but he had to step away. If we could include the OLT in this picture, not just the ONU, because we'll have some differences there a little bit, that would be helpful. So the OLT, as we're having this discussion, yes, we need to sort out the timing distribution to that, and then the OLT is used to synchronize the counter start times for its own ONUs. So that's a related aspect. But I think if we have the OLT shown as well, that would be useful for future discussion.
Well, and I think we need the ag switch. And I think we need, we're talking about NEM here, right? So, I mean, I think it's not just VOLTHA. It's the whole piece. Those things kind of need to get kind of distributed across everything. So it's not just the ONU, or it's not just VOLTHA, or, it's kind of more, or the OLT. It's kind of all the pieces.
So there's an assumption that I can tell a device at time X, start collecting data and send me a batch every Y minutes. Is that accurate?
It depends which device you're talking about. So the ONU is going to have, for the specific counters, it'll be 15 minutes is typically what you've got there.
But you tell the device to
OLT
send
is
me
going to be.
counters.
Pardon?
You tell the device to send counters every 15 minutes, and the device does that.
It depends if you have that set up. I don't believe, and if Chip was on here, he could say how things are being done. I don't believe that is proactively sent. You can go pull it. So if the ONU, it's got its current counter and its previous 15-minute interval. So that 15-minute count for the previous synchronized to the OLT interval, that one can be pulled within that 15-minute and you'll get the same value. If you want the incrementing count, you'd go to the current value and pull that one instead, and that should reset at the end of that 15-minute, and the pointers will swap.
So the device is doing some internal batching. The device is doing some internal batching, and I think what I was hearing previously was it's desirable to be able to tell all the devices to start that internal batching at the same time. Is that accurate?
That will get that.
I agree with that statement, and the caveat is not all devices behave that way. So it sounds like generally ONUs over OMCI behave that way, which is good, but not all devices, I think, can be guaranteed to behave that way. And I think what Tom was saying earlier was it's up to the adapter to make everything look kind of the same. And I would agree with that statement.
I guess I'm wondering, though, if that behavior is something that we want to generalize down at the adapter or not. Again, I come from more of the hey, if I can get data up into a single place, I can look at that data all sorts of ways, including bucketing it based on when data was collected. And so I don't believe that, minus the ability of the hardware to say, give me 15-minute intervals starting at time X, that in a distributed system such as this, you're going to actually get any more accuracy trying to do that at the adapter versus trying to do that in a northbound system on the right. And so
data points as a ONU.
Right. And if you're not going to get any more accuracy, then you might as well do it on the write and not in the adapter, because then you have a little more flexibility with what you want to do with that data and how you want to manage it.
Well, the question is do we have the system? So we have an expectation at the top of what the data looks like, and we have something in the middle just pushing up something else, and now we have to create a system that doesn't exist today that transforms the stream of flow with some fuzzy logic, artificial intelligence, fancy time series database queries into what we want on top. So, I mean, I'm worried about implementing that fuzzy logic time series database, let me build intervals type of system. I'm worried about who's going to implement that.
Right. But you're talking about having the adapter do that same type of logic, and it's really not that complex of logic. Right. Someone has to do it. Whether you're going to say it's in the adapter or northbound, it's the same logic, and someone's going to have to implement that.
I'm gonna. Go ahead, Mike.
No, it's okay. I don't think it's the same logic. I think ensuring that you collect data at the right time is very different than trying to amass a whole bunch of data into, oh, what was the right time and how did it get collected, and oh no, I just got things that are kind of going off there. I think it's a very different level of complexity, but that's my personal opinion. So others can have opinions too. So that's my personal.
Let me make a proposal, because I know it was with specific. Had a specific discussion with Tibbet last year. It was a VOLTHA session, so we go back and refer to it, but it was on the order of a year ago. And what we need to do is revisit something with them. So they had a very specific reason, and it was PON related. It wasn't ONU related, so it was less data points. And so what we there's something that I propose we go off and look at and make an assumption today that my intent there was to make an exception for how a specific device that didn't provide what we had to take care of it. At that time, we weren't talking about SIBA. Actually, it was kind of, or as SIBA was originally being conceived at the time, on the order of a year ago. So I didn't think of this problem being moved to the right then. That's why I brought up, we talked about this problem on the left, and we were trying to solve it there for a specific thing. And what it essentially would mean is, okay, when you have this time, let's say you're collecting, let's say you're doing this thing for the ONUs, and let's say the ONUs has the hardware timer set up, so it knows all the ONUs say collect at the same 15-minute interval. They all have the same clock because VOLTHA told them what the clock was. Well, VOLTHA's still going to have to go and pull through, like these arrows through the ohm state, just like Julie said. And what we were going to have to do was hit the timer, the same 15-minute timer, and go pull the pawns and get the pawn information. And we needed to do it probably within a few seconds of variation, so that we would say, okay, we're close enough to a 15-minute interval. We're going to have some variation on it. We'll live with it. We're going to have to run some tests on how that works. One thing about this is, so from a scale perspective, when you go do this OMCI poll, you may take close to your interval to get your last interval. We've seen this before in the real world. That's a scale test. That's at your largest scale. Can you go collect your last interval and be done? Because you will not stay up then. You will not stay up to what you're trying to do to move everything from the blue box to the green box to the right of it every 15 minutes, if that's what you're trying to do. And then you have to start asking yourself, well, let's make the interval longer, things like that, if you're trying to accomplish it. Let's say the most data points are on ONUs and a scale perspective. So short answer there, my proposal is if there's any exception with some hardware, we're going to work that and figure out what that is before we start pushing a solution to the right. Because we start making assumptions about pushing to the right. Let's not do it to, we have more of a threshold to do that. I don't think it's the right thing to assume more work in general on anything until you know what problem you're trying to solve. And that it's especially given that we know it's a corner case or a different piece of hardware, and trying to, in the spirit of this, to minimize the VOLTHA work as well.
So it sounds like one of the points.
You really know it.
Oh, go ahead, David.
I was just agreeing that solving a problem is much easier if you completely understand it.
Yeah, but we never completely understand the problems. So it sounds like there's part of this issue is is the diversity of things on the left. That if I can summarize, there's two different kinds of things. The ONUs have the batching capability already built into them. They already give us stuff in 15-minute intervals. Pushing those intervals up through the pipeline is perhaps easy. Other devices like the OLTs do not implement these intervals. They might only implement a counter, and it's up to us to get this counter at predictable times. Ideally, we would get this counter exactly every 15 minutes so that the intervals would be in correspondence with the ONT intervals that we're collecting. I guess it comes down to whether we can meet that idealness or not. Does that sound accurate?
Sorry. Why? I have to take a health break. Do we really know ONU has the capability to do every 15 minutes on periodical reporting? Is that what I'm hearing?
Yeah, I'm pretty sure.
That's how it's structured in the PM OMCI MEs.
Oh, okay.
Yeah, it was actually somewhat when I was trying to visualize this stuff in Prometheus months ago, and it was actually somewhat of a hindrance that the OLTs we were getting fine-grained data, and the ONUs we were getting this 15-minute interval stuff, and I couldn't find an easy way around it. So that's definitely the behavior we observed. Is that's what we got was 15-minute intervals.
Okay, and then on the OLT side, is that the OLT adapter's responsibility to just pull and send? What I'm saying is, I don't think we want what I'm saying is someone has to, if the device doesn't just automatically send the counter I have every 15 minutes, it could be accumulated until it got reset, right? So I'm sorry if I redirect the discussion here a little bit. So is that, if that's the case, if the particular ONT doesn't do that, I don't know whether Edge Core does that. We have the Edge Core here. Does it mean the OOT adapter itself need to do that kind of pull or some kind of trigger mechanism so that the data will just send out?
So the thing is, Sean, if the device has the last bin, then you don't need to have it necessarily push the data to VOLTHA. If it can do that, that would be great. Actually, that would reduce the polling.
Right.
But you actually have to do the polling for the ONUs, even if they have the last bin, because there's not a concept of the ONU sending the data left to right on OMCI. So Julie was saying that she confirmed essentially that this should be a two-way arrow on OMCI, which means that even though you had a bin on ONU, you are going to have to pull it, which is actually the most scale in VOLTHA, because there's, on the order of 32 or 64 or 128 type of ONUs more than your POMs. So, you're going to be polling some with ONUs if you're collecting ONU periodic data. because this is really you have to initiate from the VOLTHA blue box to the ONU and then get the response back to get the data. You don't, yeah.
Right, and to be specific, right, it's not a VOLTHA core initiated poll. It's probably just a VOLTHA adapter, right? The device adapter will initiate that.
Right, and so the question is, your question is, in a PON case, with the hardware, the PON registers for the VOLTHA adapter actually be sending a one-way, like this, if you said this ONU was an OLT instead, and it was meant the PON information, and it's not OMCI because it's on the VOLTHA,
on the OLT, right.
On the OLT. Is that a push, or is that a poll for those registers from a VOLTHA adapter perspective? And it doesn't need to be a push if you have the registers for the PON data in the last interval for the PON. It can be a poll, and it's going to be much less polling than number of ONUs. It probably is going to be no problem for scaling. So when we were talking about it for PON collection last year, we were thinking, well, you could probably, number of PONs, be done within seconds or even fractions of seconds by the time you set up all your requests to go get that information from it. So that needs to be done with performance testing, scale testing, and everything. But you would have the ability to collect your last minute hardware interval that way. And if there was an exception, you could say, well, I'm going to go I don't have a last interval because that hardware device didn't provide a last interval. It provides a current interval, and then I will do the math off of the current interval, or it will reset, and I would use that value as the value since I last polled, which I thought I did about 15 minutes ago, and then I'll normalize the data against the relative timestamps and all that. So we can write this up with respect to those different models and get more specific. But all I was talking about was, and you've been asking about, is what you do between the blue VOLTHA box to the left, and we can get very specific about that, and then say, okay, what's actually happening in the adapter and the adapter discussions for this. I think that makes a lot of sense to your point of your question. So that's what we should do.
Yeah. Okay. And Scott, the other thing is, I think a lot of discussion here may apply to the ONOS FCAPS too, the other brigade. Do you think there will be some overlap mechanism or, principle?
Yeah, we'll have to talk to the people working on that. I think that's Zach is perhaps managing that brigade, so I'll get in touch with him and see where he's at. But I think certainly if we can have predictable mechanisms and consistent mechanisms across the board, I think that serves us more than having divergent, unpredictable mechanisms. If we could have everyone talking on the same intervals and everyone implements, or everyone's API implements a binning abstraction, that's a benefit rather than ONOS doing something different. So I agree with you there.
Right. And usually ONOS probably doesn't deal with the devices directly, but potentially, I don't know. If you want to get Trellis into the picture, that's even a little bit bigger, right? So, okay. Do we need to continue this discussion next week? And I do think we need to get other service provider involved on this discussion too.
I think it would benefit us to discuss again, maybe before presenting to VOLTHA. So we really didn't talk about the immediate API at all during this. Go back to a picture during this call. So I think certainly a little bit of drill down on that as well, or unless the silence means everyone agreed on how the immediate API works. But who else did you say you'd like to get involved, Sean?
Deutsche Telekom and Turk Telecom.
Yeah. And when would we involve them in a Monday meeting, or would we have another meeting?
I don't know. To me, I think maybe one of the Thursday meeting on the VOLTHA call, and then when we present what we have, and we make sure they attend, and then if they can attend Monday meeting at the same time, also that I think that would be great. So either way, I because they are developing something, we just want to see what they have in mind, and then they're developing also, right? I don't know whether let me Scott, let me involve you and talk to them and see whether they can join next Monday. I don't think
Okay,
we
great.
will be able to present this Thursday anyway. So maybe if they can join next Monday, I think that's perfect.
Okay, that sounds good. So we'll plan on continuing this discussion next Monday. I will add more colored boxes to the diagrams, and hopefully we'll come a little bit further longer. It does feel like we're slowly converging on understanding our requirements and coming up with a proposal. So I think we're making progress. Continue it on Monday.
Okay, great, thanks.
And I think we're at the top of the hour, so I think that's it, unless anyone has a really quick point you'd like to make. Okay, well, thank you everyone for attending, and we will talk to you again on Monday.
Okay, great, thanks.
Bye, everyone.
Thank you, guys.
Thank you.